Go ahead. Grams to moles, yeah. So we're given grams of H2 and Br2. So we can take the masses of the reactants, convert those to moles. Then what? Divided by the volume to get moles per liter. Okay, we have a 2-liter vessel. Once we have concentrations in terms of moles per liter, then what can we do? Go ahead, Brittany.
Find the equilibrium concentration of hydrogen and then subtract that from the beginning concentration.
Yeah, so find the equilibrium concentration of hydrogens. We have that mass. Okay, we can convert that to moles as well, and then moles per liter. And what method are we going to use for that? To find those equilibrium concentrations? Go ahead. Ice table, yeah. So the first thing is to get everything in terms of moles per liter. Then use an ice table where we're going to do our initial concentration, our change in concentration, and then equilibrium concentrations. And if you recall, we'll set up the reaction, the equilibrium, and then do initial change equilibrium. So go ahead and work on that. Check with your neighbor. And we'll see if we come up with the same values. Let's find both the equilibrium concentrations and the value of K, or K sub C, as is mentioned. Here, we'll make your lives easier. No one needs to be calculating molar masses. H2, Br2, 159. matter where you've gotten, let's sort of take a look at what I've written here for my ICE table. So without showing my work, I've put in the initial concentrations of H2 and Br2. I have 0.3435 moles per liter of H2, 0.220 moles per liter of Br2. For my change line, again, no initial concentration of HBr. For my change line, I have minus x for H2. Okay, there's one stoichiometric coefficient, so that's going to be minus x for Br2, and then with the product side, plus 2x for HBr. Easy to forget that too, okay? Everyone good there? Okay. So then I have an equilibrium concentration. When we were given one in the problem, we said at equilibrium, the vessel is found to contain 0.566 grams of H2, which ends up being 0.1415 moles per liter of the H2. And we need to do is figure out what x is, okay? So in order to find x, we're basically going to solve for x in the H2 column. What I mean by that is we have 0.3435 minus x equals 0.1415 moles per liter. And when we solve for x, we'll get x is equal to 0.2020 moles per liter. Everyone see that? So we were given that equilibrium concentration. We know that we started with 0.3435. We lost some amount x. We're able to find whatever x is because we know how much we have left over. And then, so that is the concentration of, oh no, that is just x. For the concentration of Br2 at equilibrium, we're going to have 0.220 minus 0.2020. And so we end up with 0.018 moles per liter. And then for HBr, we're going to have 2 times 0.2020, or 0.4040 moles per liter. Okay, everyone okay with that? Questions on anything? Yeah. Where did we get that? So we take, because we have, we know our initial concentration of H2 and we know the final concentration at equilibrium of H2, we can figure out how much has reacted away by taking this value minus this equals this. So that's here. And then solving for x. So that is how much has reacted of H2. Then we use our stoichiometry and we say, okay, if this amount of x has reacted away, 0.2020 has reacted away, that same amount has reacted away of Br2 because of the stoichiometry. Okay, and then so we can figure out how much is left over here. So now we're solving this. And then with the HBr, we formed, so plus 2x. And so we knew what x was, and so we can solve for that. Does that help? Okay. So then the last thing was to solve for K, Kc, Keq, whatever we want to call it, just not Kp. And we basically need to write out our equilibrium constant expression and then plug in the equilibrium concentrations. So we're going to have the concentration of HBr squared over the concentration of H2 times the concentration of Br2. And don't forget, you do need to square that HBr concentration. We plug in our equilibrium concentrations. Oops. solve, and we'll end up with KC equals 64.1. Questions on that part? Really easy to forget that square. All right.